Hello guys, welcome back to Maths on African Motives. Still working on our mathematics grade 10 and this is a revision that we are going to have working on our inequalities. We managed to separate this topic from the first part, worked with the normal, which is the simple inequalities, and also working with compound inequalities from the separate video. So make sure that you watch those classes so that you'll be able to understand, because this is just a revision, a recap of what we talked about in those classes. All right, so the first part of the inequalities, these are just simple inequalities. Remember, I told you that simple inequalities, you just solve the same way you used when you were solving linear equations. The only difference is going to be affected whenever you divide by a negative or to multiply by a negative, and I shall explain that in the questions that follows. All right, the first question that we are given on number 1 was x plus 18 in this case is less than or equal to 9 minus 2x. We are asked to solve the following inequalities and represent the solutions on a number line. So we have to solve, and also do not forget the solution has to be represented on a number line. So like I said, the way that you solve inequalities is the same way as you are solving equations. So that means I can take the minus 2x to the other side of the inequality sign. So if I transpose this to the other side, it becomes a positive. It was negative 2x, so it becomes a positive. Then also, I'm going to transpose 18 to the other side of the inequality, so that here I just remain with the variable, which is x. All right, so I'm going to remain with x. If I transpose the negative 2x, it is now this side. It has crossed the inequality sign, so it changes the sign. As it goes this side, it was a negative, so it becomes a positive 2x. It changes the sign. So this is less than or equal to, already we have got a 9, okay, on the right-hand side of the inequality sign. Then we transpose the positive 18, take it to the other side of the inequality. It changes the sign. It was a negative, it was a positive, it becomes a negative. So that's how you play around, all right? Take the part with x to where x is, it changes the sign. You take the number 18 to where there is another number, which is 9, it also changes the sign. It was a positive 18, it becomes a negative 18, just like your normal equation, all right? Then here, this is the same as 1x, so you're going to add 1 plus 2, which is 3. So this is going to give us 3x, which is less than or equal to 9 minus 18, which is negative 9. If you do not understand this, the part of your directed numbers, you're still having a confusion, the calculator is there as an assistance always in exam. So that's 9 minus 18. And this is going to give you a negative 9. So for you to find x, you can divide by 3, divide by 3. You are dividing by a positive 3, so this does not affect the inequality sign. All right, so if we divide our answer by 3, we're going to get a negative 3. Okay, so dividing by a positive number, like I said, it does not affect your inequality sign. The inequality sign remains as it is. All right. Let us check another part of the question. Let us check question 2. If we're going to see the part of a negative that I want you to understand. X minus 3 is less than 2x plus 5. This is what you're given. All right, I want you to understand that concept of the negative. Okay, if I was to take this the same way as the previous case, I take 2x to the other side, it becomes a negative, then negative 3 to the other side, it becomes a positive. So the moment we take this, already there's an x which is on the left-hand side, so that will be x. Then we take them 2x to this side, it crosses the inequality sign, it changes the sign, it becomes a negative 2x. This is less than, all right, already on the right side of the inequality, there is a 5. Then we've transposed the negative 3 this side. It becomes a positive. It was a negative, so the sign changes. It's now a positive 3, okay? So take note here. This is 1x minus 2x. So it's 1 minus 2, which is minus 1x, or just minus x, or minus 1x, is less than 5 plus 3, which is 8, all right? 5 plus 3, which is 8 in that case. So I want you to take a closer look here. 5 plus 3, which is 8. We are supposed to have the value of x, not minus x. This is a minus x, as we need the value of a positive x. So what you're supposed to do is to divide. This is the same as -1. So you divide by -1, we divide by -1. The moment that you just divide by this negative, the sign reverses, the sign changes, it reverses or changes. You're supposed to change the sign, right? So it was less than like this. So you're going to see the sign this way. It reverses. So x is now greater than 8 divided by -1. That will be a -8. Or you can use your calculator to divide. So the sign, it reverses. All right. Take note, the question was not just to solve. They also want us to represent on the number line. All right. I forgot to do that on the first question. Let us just do this one on this one. Remember, we talked about the issue of a number line. All right. We talked about this issue of a number line on the introduction. So if x is greater than -8, what is important is where the -8 is. Let's say this is where we have our -8. All right, definitely our 0 can be somewhere there. All right, so the greater than, we just indicate a circle at 8. You do not shed anything. All right, you do not shed if it is greater than. You only shed when there is an equal to. That's where you shed the circle, right? But in this case, there's nothing that you do, just draw a circle like this. So which values are bigger than -8? Greater than, x is pointing, x is bigger, it's pointing -8. So we need values that are bigger than -8. So values bigger than -8, these are values such as -7, -6, -5, and so on. So these values are found on the right side of the number line. So you indicate the arrow there. The arrow is for you to is showing us that the values are on the right side. Up to infinity, they do not end. They are endless values. Talk about 0, 1, 2, 3, 4, 100, 1,000, 1 million. All these values, they are bigger than -8. They are greater than -8. So that's the idea of the number line that you are presenting, all right? So this is how you solve and also present on the number line. Just have to be careful on your presentation of the questions. So I explained this, and I told you guys you just have to be careful as you answer your questions. So I'm just gonna allow you guys to try number 3, then let us try number 4 together. We have got brackets, but I also explained this on the introduction where we've got brackets. Let us see what we are given on number 4. That's minus 2x, right? That's x there, sorry. This is x minus 1 is greater than or equal to 0, like that. So as to solve this and also to present the solution on a number line. So this is what you're going to do. There are brackets, so you're supposed to expand the brackets, right? How do I expand the brackets? I just have to distribute the first bracket by 4. I have to distribute everything by 4 inside of the bracket. So that'll be 4 times x, 4 times -3. Okay, so 4 times x, this is same as 1x, so it's 4 times 1, which is 4x, 4 times -3, which is a -12, right? We can just use a calculator. -2 times x, this is a 1, so it's -2 times 1, which is -2x, -2 and a negative, that'll be a positive, negative, that's a positive. So this will be a +2, greater or equal to 0. Like I said, you can use your calculator for the simplification of these. So what you're going to do is to collect the like terms already. We've got all the terms on one side of the inequality. Before you transpose anything, just collect the like terms, the terms with x. These are the like terms. So this is 4x minus 2x. So we are going to have 4 minus 2, which is 2. So that will be a 2x. Then we've got a -12 and a +2. So -12 plus 2, that's a -10. Or we can use the calculator like I said before. So let us just see on our calculator, we've got negative 12. That's a negative 12 like this plus 2, which is going to give us a negative 10. So we've got negative 10. This is greater than or equal to a 0. All right. Now that we want to solve for x, this is a linear inequality, just like a linear equation. We are supposed to transpose the constant to the other side of the inequality. It was a negative, so it is going to be a positive on the other side. So this does not affect the inequality. To transpose a term, whether it's a positive, negative, this does not affect the inequality sign. All right. So to find x, you're going to divide by 2. Since you're multiplying here, x is going to be greater than or equal to 10 divided by 2, which is 5. So remember what I said, the inequality sign is not affected because you divided by a positive. It is only affected when you divide by a negative or multiply by a negative, all right? And after that, we are supposed to present this on our number line. So the values of x, let's say this is where we have our 0. This is where we're going to have our 5. So at 5, this time there is an equal to. If you take note here, there is an equal to. So I said whenever this equal to is there, we are going to shade the circle. So which values that are greater than 5? The 5 is included, but also we need values that are bigger than 5, greater than, talk about 6, 7, 8, 9, 10, 11, and so on. So these values are on the right side, all right? So you're going to just indicate the arrow showing the right side to show that the values are going to the right side up to infinity. They do not end. So these values that you are given of x, they do not end, okay? They do not end at all. That is how these questions can be given as, so like I said, I want you to try number 3. Gonna move on to B. So on B, we are given again to solve the inequalities, just like the previous case. We are still solving the inequalities and represent the solution on a number line. But the difference is that we've got okay brackets and we've got the fractions and this and that. So we talked about the issue of fractions. Again, it is the same thing that you're supposed to do. The same way that you play around, you work with equations. All right, the same way that you just apply your equations. Okay, let's do this. This is x over 2 is greater than 1. Okay, this is what you have. X minus 3, x over 3 minus x over 2 is greater than. So before you work with the fraction, be able to analyze your fraction. This fraction that you see could have been combined. We could have combined this to be a single fraction because this is the same. This is x, this is x. So you can just subtract 1 over 3 minus 1 over 2. You're done. But if that is not understood, like you do not understand that case, maybe, or it can be like difficult for you to tell that these terms can be added together, can be combined, then on another part, you are not combining anything. On another part, you are combining. On another part, you are not. So it will be of, what can we say? It can be of confusion for you to do that, to say, this question you are going to add, another question you are not going to add, you are going to use another method at all, or another situation of presentation or calculating. So how do we avoid that? All right, sorry for that, guys. This pen of mine, I'm just fixing it so that it can be fine. All right, sorry for that. So how do you avoid that? This is how you avoid. Just determine the LCD. Just find the LCD of the given fractions. All right? This is same as over 1. So you determine the LCD of the given fractions, which is, we're considering 3, 2, and 1. So the LCD is going to be given as 6. All right, 3 times 2 there's a 6, the lowest common denominator. So with the LCD that you've determined, you're going to multiply each and every term. Multiply by 6 here, we multiply by 6 here, we multiply by 6, each and every term of the inequality, just like what you do on an equation. So this is what you're going to have. 3 into 6, that's 6 divided by 3 is going to give us a 2. So that's 2 times x, which will be 2x, all right? Minus you do the same thing. 2 into 6, that's 6 divided by 2, it's going to be 3. Then 3 times x, which will be 3x. So that will be minus 3x is greater than, all right? That's 1 into 6, that's a 6. Then 6 times 1, which is just a 6. Okay, so this will be a 6. As you can see, we no longer have the fractions. We have cleared the fractions. So just to clear the fraction, we have to multiply each and every term by the LCD. So like I said, we could have added these two, combine these two, I mean subtract. It was what we're going to have one and the same thing. Okay, anyways, 2x minus x, that's 2 minus 3. 2x minus 3x, so it's 2 minus 3, which is going to be minus 1x, which is same as minus x, is greater than 6. So remember, this is the same as minus 1x. So to find x, we have to divide by -1, by -1 both sides, so that this becomes a positive x. But remember what I said about the inequality sign, because you are dividing by a negative number. The inequality sign has to reverse, it has to change. So this changes. So it's now 6 divided by -1, which is a -6. So as long as you understand this, guys, you are not going to have any challenge on your inequalities. And also to represent on your number line, -6, let's say this is where we have -6. Maybe that's where we have a 0 here. So which values of x are we considering that are less than -6? Less than, we do not shed, we just draw a circle. But which values are less than, we're talking about smaller than -6, -7, -8. These are these values. So these values are on the left side, talking about -7, -8, -9. Here we've got -5, -4. So these values on this side are the ones that are less than. All right, -7 is less than -6. -100, -100 is less than -6. All right, the bigger the number with a negative, that the smaller that number the smaller that number it is. Okay, so once you understand this, you're not going to have any problem in answering of questions. So this is the same situation that you see wherever we're given these fractions, just going to apply the same thing. So I want you to try number 2. We're going to try number 3 together. Number 3, we are given y plus 5, that is over 3, plus y is less than or equal to 1. Okay, so it is the same situation that you're going to apply this. Remember, I told you guys from our numbers that any number that you have, any whole number, can be written as a fraction. At the moment we write it as over 1. So y can be written as y over 1, 1 over 1. So that we can properly see our denominators, that what is the LCD of these denominators. We've got 3, 1, and 1. So the LCD, there's going to be a 3. So like I said, you multiply each and every term by the LCD. So here, we're going to multiply by the LCD, which is 3, multiply by the LCD, multiply by the LCD, which is 3. Each and every term. So here, this is going to cancel, the 3 and the 3 is going to cancel, they're the same, meaning you're going to get a 1. So in actual sense, if there is a number here, maybe it's a 2, it's a 3, it's a 4, or whatever that you get, you're supposed to write it like this: 1 into the bracket, because this is an expression. There are 2 terms, y and 5. So you're going to open a bracket for that to show that this number is going to multiply everything. So like I said, because it's a 1 does not affect, but in a case that there's a number there which is different, it's a 2, it's a 3, there is no way. You have to open the bracket and multiply each and every term by that number, okay? Then on this part, it's just a single term. There's nothing that you're going to need. They just multiply 3 times y, which is going to be 3y is less than or equal to 1 into 3, that's 3, then 3 times 1, which is 3, okay? The 1 expands the bracket. So because you are multiplying by 1 does not affect 1 times y, it is just going to remain as a y. 1 times 5, this is going to remain as a 5. Okay, plus 3y is less than or equal to 3. What do you notice at this stage? You notice that we do not have brackets. We just left with a normal inequality that we are used to, whereby we can collect our like terms. This is the same as 1y. So we can collect like terms 1y plus 3y. That's 1 plus 3, which is going to be 4y plus a 5. This is less than or equal to 3. All right, that's it. 4y is going to be less than or equal to, we transpose the 5 to the other side of the inequality. So the moment we transpose this, it was a positive. So on the other side is going to be a negative 5. So that's 3 minus 5, which will give you a negative 2. Or like I said, for any misunderstanding that you have on your directed numbers, do not hesitate to use your calculator. It's there as an assistance. 3 minus a 5. This will give us a negative 2. So to find the value of y, you're going to divide by 4, and we are dividing by a positive. So this does not affect our inequality sign if we divide by a positive, all right? So that's negative 2 divided by 4. And that will be a negative half. So that means in this case, y is less than or equal to a minus half, which is a minus 1 over 2. That is going to be our solution. Y is less than or equal to minus half. All right. So on a number line does not mean that you have to like indicate according to the y-axis. You can just indicate the normal way where the y that we are used for the x. All right. So this is it at negative half. Maybe that's a 0 here. A negative half can be maybe somewhere there. It's on the left side, okay? So the y values that we are talking about, or the values that we need that are less than or equal to, all right? The moment that we are saying less than or equal to, we are going to shade the circle at negative half. But which values? The values that are less than, these are values on the negative side, -1, -2, -3, -4, -5, negative, up to negative infinity. They do not end. So that's why we're just going to indicate with an arrow like that. So that was the idea of this question, right? Expand, clear the fractions by multiplying each and every term by the LCD, like I explained before. So this is what you're going to do. Wherever there's a fraction, I want you to do the same thing. But if you consider that on question 4, you have to be just a little bit careful. All right, at question 5, you're going to try, you just have to expand your brackets. You see that those x squared something will just expand, you will just cancel. All right, just don't be scared about the brackets, guys. Okay, don't be scared. Just use your normal expansion of brackets. All right, so I'm just going to try question number 4 with you there. All right, don't be scared also on this one. Let's see together. We are given on question number 4, that is 3y plus 2 over 4. All right, minus y minus 6 over 3 is greater than 0. This is what you're given. Okay. So like I said, the first thing, determine the LCD. 0 is same as 0 over 1. All right, 0 divided by 1, that's a 0. All right, 1 divided by 0 is the one that does not exist. This one does not exist. It's infinite. We do not have the answer there. So the LCD of these given denominators that we have, which is 4, 3, and 1, is going to be what? That is a 12. All right, just going to multiply 4 and 3, which is 12. So if the LCD is given as 12, we are going to multiply each and every term by the LCD. Multiply by 12 here, we multiply by 12 here, we multiply by 12 here. So in the normal sense, you're simply dividing 12 divided to 3. That is the case of the question. That is what is exactly happening there. So it was just going to cancel 12 divided by a 4, this 4. If you divide 12 and a 4, you're going to get a 3. But what is going to happen with this 3? It is supposed to multiply everything that we see in the numerator, everything that you see here as it is. It is supposed to be multiplied by 3. So it's going to be 3 into 3y plus 2. Okay, minus 3 into 12. That's the same thing, 12 divided by 3, which is a 4. So the number that we get there is supposed to be a -4 because we've got a negative here. So we've got a -4, which is supposed to multiply everything that we see here in the numerator, which is y minus 6. So you're going to open the bracket for that, y minus 6. All right, this is greater than 1 into 12, that's 12 divided by 1, which is a 12. Then 0 times 12, any number times 0, that's a 0. So that's why I say do not play with people without a value, because the product of something without a value is always a 0. If you play with someone without a value, you end up you yourself without a value. So that's the true part of our mathematics. Okay, so avoid a person without a value. Okay, anyways, let us expand our values, our brackets, and see what you're going to have at the end, because we've got brackets. Now we're done with the fractions. Now we have got the brackets. So to expand the brackets, you just have to distribute everything by the term or the number out of the brackets. So that's 3 times 3, which is 9. So that's 9y. 3 times 2, which is 6. So you're multiplying by 3. 3 times 3, 3 times 2. 3 times 3, 9. 3 times 2, 6. You do the same thing. Negative 4 times y. Negative 4 times negative 6. All right. So negative 4 times y is going to give us negative 4y. Negative, negative, that's a positive. So this will give us a positive 24. 4 times 6. Or like I said, on your calculator, you can simplify anything. So please do so to verify your calculations whenever you are not certain, like this negative 4 times negative 6. So you can see this will give you a positive 24. Okay, so this is it, greater than a 0. Collect the like terms. So that's 9 minus 4, which is a 5. Okay, 9 minus a 4, which is a 5. So we are going to get a 5y, in this case 6 plus 24, which is a 30. We're just going to add 6 plus 24, that's a 30. So this is greater than 0. So what you're going to do is to transpose as the previous case. That will be 5y is greater than, right? Transpose 30 to the other side of the inequality. It was a positive this side. So the moment it goes to the other side, it becomes a negative. It changes the sign. So it was a positive, so it becomes a negative 30, right? So divide by 5, you get the value of y. So this is the solution. Y is going to be greater than. We are dividing by a positive number. So this does not affect our inequality. Our inequality is not affected by that. So negative 30 divided by 5 is going to give us a negative 6 on your calculator, because it's going to get a negative 6. So y is greater than negative 6. So like I said, do not confuse yourself on the inequality sign. It only reverses when you divide by a negative, not when you divide by a positive. This does not affect the inequality sign. All right, and also on our number line, what is important is to indicate maybe we've got a 0 here, and negative 6 is going to be somewhere there. We are not going to shed. This is just a greater than, right? But which values are bigger than minus 6? These are the values that are on the right side. Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. All these values, they are bigger than minus 6. So we indicate our arrow pointing to the right. So that is the idea of the question. So like I said, I just want to challenge you guys with question number 5. I want you to try that question, expand your brackets. Then after that, you see that you're going to form the x squared, and x squared, they will cancel. You just remain with a linear inequality, all right? So try number 5. Then we're going to do the part C together. The part C is of compound inequalities. Remember, we talked about compound inequalities as a separate class. And I told you that these inequalities whereby you are solving, whereby there are two inequalities, all right? They've got two inequality signs that are there on the same inequality. We're going to work with two inequality signs. All right. So these questions, we are asked to solve these and also to represent the solution on the number line of whatever that you're going to solve All right, remember what I talked about? I said on these inequalities that we refer as compound inequalities, it is of best nature that you understand the solving of this linear, which is the one that we have been talking about, and also to understand that your final answers always should be in the format x is greater than a and the x is less than b. This is the format, whether here is going to be greater than or equal to, less than or equal to. But the arrows, the sign, or the inequality sign should face one direction, which is they must face the left as they are. As they are on this presentation, these inequality signs, that is how they are supposed to be like on your final answers, exactly as they are. Okay, so I said also, when you are solving these inequalities, what you just need to understand is the linear, the first part that you've been talking about. Whatever that you've been doing there is the same, only that you're doing it repeated. You're doing it twice. You're doing it on both inequalities. So just imagine we are solving an inequality like this side only. What were you going to do? You're going to transpose -1 this side, which is the same thing that you're going to do. Let's say you are solving this side of the inequality. You're going to transpose -1 to the other side. So it is the same thing. So whatever that you're going to do should affect both inequalities. So you're going to transpose -1 this side. We also transpose -1 that side. So it was a negative. This side, it becomes a positive. So -2 plus 1, let's say what x less transpose -1 the other side, it becomes a positive. So that's 5 plus 1. Whatever that you do, you transpose it both this side and also the other side of the inequality. It was a negative on the other side, positive, positive. All right, -2 plus 1, that's a -1. Okay, we're gonna put our inequality sign as it is, less than 5 plus 1, which is a 6. So as we can see, we have determined the x that we wanted. There's nothing that we're gonna do there, not gonna divide by anything. We have the x. All right, we have the x that we wanted. So this is how you can solve this inequality. And on your number line, the numbers should be taken in within. It's a boundary. It's a limit. Your numbers, they are limited within -1 and +6, where we are going to have a -1 and a +6 somewhere there. So at -1, you're going to shade because there is a equal to. Wherever you've got the equal to, you shade. At 6, we do not have that, so we're just going to indicate a circle that is not shaded. Then we join. That is, the values are in within. Like I said, it's a boundary. The values are found in within. So that's, you just join in within these 2 points. That's where your x values are located, are found. They are found in within this space. Okay, that was it. Let's check. This is the same as the second question. As you can see, it's also a clear type of a question. Let's just see what we are given. All right, there we are given -3 on number 2. We are given x plus 2 is greater than. So let's just write as it is. I'm just gonna write as it is. So it's the same situation. If you see here, just gonna transpose 2 to the other side. It becomes a negative. 2 to the other side, it becomes a negative. This is the part that is affecting our x, a +2. So transpose it, take it the other side, also take it the other side, just because we've got 2 inequality signs to be considered. So this will be -3. So -2 when taken this side, I mean a +2. This side, it becomes a negative. So it will be -2 is less than. We are left with x. All right. We take the same 2 to the other side of the inequality sign that we have here. It becomes a negative, just like the previous case. So it will be 4 minus 2. So that's it. We are remaining with x. So you just have to combine -3 minus 2. That's a -5. All right. The inequality sign as it is. All right. 4 minus 2, which is going to give us a +2. So that's our values. They are taken in within -5 and 2, but not involving -5 and 2. So this is how you present on your number line. You're just going to indicate the major points that you are given, which is at -5 and at +2. So we are not going to shed these circles because we do not have the equal to is not there. So we are not going to shed. All right. Just draw these circles, then you join them. All right. So that's it. Join these circles up to this point. So that's it. That's your number line for compound inequalities. So if you have watched the introduction of a compound inequalities, we see that we already talked about this. And all right, so I just want you to try these questions. Whenever there is this number, you're just going to divide by that number. There's a -2x, you're going to divide by that. So I'm just going to try number 4. It is similar to that. So I'm just going to do number 4 with you. But you see that it's just similar to that. -8, we are given the inequality sign. 3x -2 is less than 4 like this. So this means 3x -2 is greater than -8. 3x -2 is less than 4. All right. So the same way, just like what we solved there, before we think about what is affecting x directly here, let us remove the -2 because the -2 is just being subtracted. So it can be transposed to the other side of the inequality, and whatever that you do should be also done on this inequality. All right. So that will be -8 -2 to this side of the inequality. It becomes a positive. It is a negative. So that will be a +2. Less 3x, we do the same thing. -2 to this side, it becomes a positive, just like this part. So it will be positive. So that will be less than 4 + 2, right? We have taken -2 to this side of inequality, also on that side. So, okay, let's add. -8 + 2. This gives you a -6. Okay, you can use your calculator for that. 3x going to have less than 4 + 2, which is going to give us a +6. All right. This is the situation that is happening, which is different from the last one. On the last questions, we were automatically having the answers x is greater than 3 is less than 7. We were having x, not 3x, not 2x, not -x. It was direct x. But this time, if you check, there's a number that is affecting here. So how do you treat this number? Just like a normal inequality, I just have to remove this number here. How do I remove this? I have to divide by that number. So whatever that I do is supposed to affect both. So if I divide by 3 here, I also supposed to divide by 3 by 3. And I'm dividing by a positive number. This does not affect anything, does not affect. So it's going to be -6 divided by 3, which is -2. 3 and 3 cancels, so that will be x less than 6 divided by 3, which is +2. So that's the idea there. That's the idea. There's no need for you to separate the inequalities, okay? There's no need for you to do that. So with this information or with this idea of the inequalities on how to solve like this, it follows that you can answer as much questions, guys, as much questions as you can. Just have to revise your question papers, all right? Do as much questions as you can. So on our number line, -2 and +2 are the most important points. And here we're not going to shed. We've got less than and greater than. So there we're not going to shed anything because we do not have the equal to. So just going to join like this, right? So that's it. That's the idea of your number line. Okay, taken from -2 up to +2, where -2 is not involved, +2 is not involved. They are just our boundaries for the given inequality. So this is what you can do. And sometimes it cannot be a condition where it is where you're dividing by a positive. Sometimes you can have a condition like this question where the x is carrying a negative. And on that condition, it's going to affect our inequality. How so? Okay, let's see that question. It is the same thing as question number 6, but I'm just going to try question 5 with you. Then I want you to try question 6. If you have a challenge, let me know, guys, on the comment section so that you can be able to do those questions that are having challenges on the questions that I asked you to try to try them. Okay, number 5, we are given 1 minus 5x, that is 1 minus 5x like this is greater than negative 9, but it is less than or equal to 21. Okay. It is the same situation that we had whereby this here is directly affecting our x. So you can just leave it for the meantime. Just leave it for the meantime. Think about the 1, transpose it to the other side, transpose 1 also to the other side of the inequality. All right. It is a positive. So the moment we transpose this, it becomes a negative this side. So that's minus 9 minus 1. All right. The inequality sign as it is, this does not affect our inequality. The inequality sign as it is, this does not affect our inequality sign. Okay. We transpose 1 to the other side, it becomes a negative, just like this side. So it's going to be 21 minus 1. Okay, minus 9 minus 1. What is it that we get? That's a minus 10. You can use your calculator, but that's a negative 10. Less negative 5x, all right? So this is less or equal to 21 minus 1. So 21 minus 1, that is going to be a positive 20. So we are back now to the situation that we had in the previous case where there is a number now that is affecting x. The only difference that we have is this number is no longer an ordinary number, just like the last time that we had. It's a negative. And a negative, whenever we are talking about inequalities, wherever you see a negative, take it with a pinch of salt. You have to take a negative with a pinch of salt. So you have to be careful about that. Why? Because it affects the sign. A negative affects the sign. So this, the moment we divide by negative 5, the moment we divide by negative 5, the moment we divide by negative 5, it affects the sign. The sign is being affected. So instead of our sign to be facing this direction, it is going to face x. It changes. Instead of our sign to be facing x like this, it is going to face the other direction because of that negative. It affects these signs. All right, but everything is going to remain as it is. Negative, negative cancel. 10 divided by 5, that's a 2. 20 divided by negative 5, that's a negative 4. All right, and this does not make sense the way it is presented. In actual sense, I said always your final answer is supposed to be given in the format x is greater than a is less than b. The arrows pointing one side, these signs, inequality signs, should face one side of the inequality, which is to the right, to the left side, not this. Yes, they are facing one side, but where? The limits here, we do not have limits when it is like this. We want to properly have our limits. All right. So this does not affect. Remember our format x is greater than a, less than b. X pointing another term. This is what is happening. X here is pointing. X is greater than or equal to. X is pointing minus 4. X is pointing. So you're just going to take x greater than or equal to. X is pointing minus 4. Greater than or equal to minus 4. But the same x that we are talking about here, it is being pointed by b. If we check here, b is pointing. B is the one that is pointing x. And x here is being pointed. This is the one that is happening with 2. Okay? 2 is pointing x. X is pointed by 2. X is less than 2. X is less than 2. So it's going to be a less than like this. Okay. So that's it. That's it. You just have to be very, very careful on your final presentation. You take this as it is, but written on the other way. This as it is written on the other way. And like I said, the format of your final answer is very, very important. So you're going to take this in between negative 4 and positive 2. At negative 4, x is not just greater than, but it's also equal to. There's an equal to there. So we are going to indicate a shaded circle at negative 4. At positive 2 is just a less than. So we're just going to draw a circle, which is not shaded. then we join in between. These are the values that are found in between -4 and what? And +2, where -4 is part of the solution. It's involved. That's why we have to shed. It's greater than or equal to -4. -4 is part of the solution. Greater or equal to -4. But 2 is not involved. It's less than 2, meaning to say 2 is not part of the solution set. So like I said, these are the questions that you're given. Just try to work on much questions as you can. Number 6 is the same thing, -2. We're given our inequality sign less than 2 like this. So it's 2 minus x is greater than or equal to -2, but less than 2. So it's the same thing. Before we think about affecting the -2, the minus x, which is directly affecting x, think about the 2 that can be transposed. We can transpose this to the other side, transpose this to the other side. So that means here we are going to have -2, -2, it was a positive, all right? Then we've got -x is less than 2. Take the 2 the other side, it becomes a -2. -2 minus 2, that's a -4, less or equal to x less 2 minus 2, which is a 0. All right. At this stage, we are supposed to divide by a negative. So you're going to divide by -1. This is -1. So you're going to divide by -1, by -1, by -1. So like I said, the moment you divide by a negative, it affects the inequality signs. The inequality signs are affected. They reverse. They reverse. It was a greater than x pointing this. Now it's going to be pointed. All right. X was being point. It's going to be pointing 0 like that. All right. And here we're going to have negative, which is going to be a 4. So the idea does not change that x is supposed to be greater than a, less than b on our final answer. This is the way of the format that we must have for the x. X is supposed to point a, this side. So x is pointing 0. X is greater than 0. So this means x is greater than 0. We take this solution. All right. The same x is less than or equal to 4. It's being pointed by 4. So the same x is being pointed by 4. Okay. That is less or equal to, less b. But this one is there's an equal to. So you have to indicate the equal to. Okay. So that was our solution to this inequality, bounded in between 0 and 4. So our number line is going to be 0, and this will be a 4. So at 0, there's nothing that you're going to do. It's a greater than. So just draw a circle. But at 4, there's an equal to that is there. Once the equal to is there, we're going to shed the circle. So this time we shed the circle at 4. Then we can join. So that's how you can present your number line. It is very, very important that you understand your number line from the presentation of numbers. Okay. So inequalities, this is what you're going to expect in your syllabus. Solving of these typical inequalities from a normal, a linear inequality to compound inequalities. That's the part of your syllabus. So just work with more question papers. After this, do as many question papers as you can so that you'll be able to understand how do they ask these questions, and you'll be able to answer any question in your final exam.